Okay, so we're looking at the next part of the topic, which is talking about arrangements. So the first one we're doing is a thing called permutations. And so when you've got things to arrange, objects to arrange, and the order is important, then what we do is what it's called is called a permutation. Okay, so it's going on a circle there. Okay, for instance, if we're picking a captain and a vice captain for a team, the captain is different from the vice captain, and vice versa. So the order that you pick the people is important. So we call this a permutation. But for instance, when you're picking the lotto numbers and you've got 6 numbers, it doesn't matter whether the number you picked is selected first or selected last. As long as it's selected, you win. So in this particular case, it's not a permutation, and you'll find out later that's called a combination. Okay, so let's moving on. So for instance, we've got 10 horses in a race, and we want to pick the trifecta. Okay, when you pick the first 3 in order, that's called a trifecta. Okay, so the order is important, and so what you can think about is in like a box approach. So there are 10 horses, so there are 10 different horses that you could pick for first place. But once that horse has been selected, there's only 9 horses left for second place, and then once that horse has been selected, there's only 8 horses left that you can pick for third place. And so in the multiplication principle, we just go 10 by 9 by 8, and that gives us 720. So there's 720 ways to arrange 10 horses into a first, second, and third. And so if the question turned into a probability of a random selection being correct, like if you choose one random, the answer would be 1 over 720. So the probability that one selection is correct would be 1 over 720. So this number, the 720, gives us the total number of possibilities. And when we turn into probability, then that becomes the denominator. Okay. So another way to solve the problem is to use the permutation button on your calculator. Okay, so it looks like this, NPR. Now on my Casio, it actually sits above NCR, which is going to be your combination button, which we'll do later. But again, like all calculators are different, so you need to find somewhere in your calculator a button that has NPR. So if you could find that, and then let's move across to the next slide. So in that 10 horse and 3 places that we're trying to pick, what we've got is we've got 10 horses and we want to pick 3 in a particular order. So if you just put 10, you press 10 and then you press shift and then you press the NPR, or NCR, then you put 3, then you press equals, and you get your 720 straight away. But I do like the box approach. Like this box approach about putting numbers in boxes also, it makes sense to a lot of kids as well, what we're doing. Okay, so I'll keep going backwards and forwards between the 2 techniques. Okay, now, in case you're wondering how it's defined, NPR is defined as n factorial, so that symbol there is called n factorial, divided by n minus r, which is going to be a number, factorial. And just in case you haven't seen this factorial thing before, n factorial is defined as starting from the number, whatever, like for instance starting from 10, and then multiplying by the number next, 1 less, and multiply by the 1 less, and then keep on going down till you get to 1. So with 10PR, 10p3, you've got 10 factorial divided by the difference between 10 and 3, which is 7. And so 10 factorial is 10 by 9 by 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1. And 7 factorial is 7 by 6 by 5 by 4 by 3 by 2 by 1. And then that set of numbers cancels out with that set of numbers, and so you get back to your 10 by 9 by 8, which is numbers in the box that we had previously. So that's how it's defined, and you do need to know the definition, okay? There will be likely questions where you need to know what NPR and later on what NCR means. So copy that down. Okay, moving across. So let's have a look at how you could approach these questions. Okay, so example 1, how many ways can 6 people be arranged in a straight line? So using the NPR approach, we've got 6 people and we want to arrange all 6. So that'll be 6 people to be arranged from 6 people. So on your calculator, we've got 6 shift NPR 6 equals 720 again. But if you were doing the box approach, 2, 3, 4, 5, 6. If you're just doing the box approach, there's 6 people that can be chosen first, then 5, then 4, then 3, then 2, then 1. Okay, so we're choosing all of them. So when you're choosing all people, then we could just say the answer is 6 factorial. Okay, so it doesn't matter which way you do. That's right. Now in this next one, what's going to happen is, if you just think the answer is 6 factorial, and it's not going to be, what happens is there's one particular arrangement of the 6 people around the circle. Okay, so that's, these people here are being arranged in a straight line. So when you look at it from the side or from the top, the order is important. But for instance, when you're looking from above, from a vertical angle, there's the arrangement of 6 people. But if this guy moves to that position and that guy moves to that position, or girls or guys, doesn't matter. So if they all move around 1, okay, if they were in a straight line, it would make a difference. But looking from above, the arrangement of the original plus moving them around 1 would look exactly the same from above. So what we do is we pretend that one person is nailed and all the other 5 are arranged around them. So when you've got a question with a circle, what it is, you just take off 1 less. So we've got 6 people. What we're doing is we're actually arranging 5 people are being arranged. So in general, you take 1 off. So it's n minus 1 factorial. So in this particular case, it's 5 factorial. And on your calculator, 5 factorial equals 1. So just be ready for when you arrange people in a circle, and you have to arrange all the people. You can't arrange some of the people. So when you're arranging all the people in a circle, look at the number and just take 1 off. What effectively you're doing is you're nailing one person to a seat and the other 5 people are being arranged around them. So copy that and then come across. Okay, so we're just going to go through some more questions. So question 3, how many ways can 8 books be arranged on a shelf? So we're arranging all of them. So the answer could be, it's just 8 factorial, and you can leave your answer, that's fine. But 8 factorial on your calculator, 8 shift factorial equals, so that equals 40,320. But 8 factorial is fine. The other way it could be expressed would be 8p8, and that also equals 40,320. And of course, if you were going to do in the box approach, it's 8, 7, 6, 5, 4, 3, 2, 1, and that equals 40,320. Okay, so that's fine. Now, what we're going to do is look at a series of questions now that get a little bit trickier each time. So, I've got 8 books to be arranged, but 2 particular books, we don't know which book, but they must be kept together. So what's going to happen is, these 2 books are going to be kept together, and there's still another 6 books. 3, 4, 5, 6. Okay, so there's our 8 books, but these 2 books have to be kept together. So rather than worrying about the NPR, let's just think of it as the factorial. So I've got 1, 2, 3, 4, 5, 6, 7. I've got 7 things to be arranged because these books have to be kept together. So the answer, so I've got 7 factorial because I've got 7 groups. I've got 6 books plus a group of books. But in this group of books, these books can be arranged in 2 different ways, which would be 2 factorial. Okay? So that answer would be acceptable. And then on your calculator, if you want to get an actual answer, so the answer would be 10,080. So let's just go through that one again. So we've got 8 books, but 2 books are kept together. So there's my 2 books being kept together. So I've got 7 things to arrange. 1 group of books and 6 individual books. So that is 7 factorial. But the 2 books back here, the first 2 books, can be arranged in two ways, which is 2 factorial. Okay, moving on. Okay, so now we keep on going with this idea with the books. Okay, we've got 3 different science books, not the same science books, and 5 different math books to be arranged on itself. So A, how many ways can they be arranged if there's no restrictions, and then how many ways if the subjects are kept together, and how many ways the maths book must be at each end. Okay. So 3 science, 5 maths. So in the first way, there's no restrictions, so I've got 8 books. Okay, so the answer to the first one is just 8 factorial. In the second one, I've got the subjects are kept together. So I've got one group of science books, one group of maths books, so I have 2 groups to be arranged. Okay, so there's 2 factorial ways for the science and maths to be arranged as 2 groups, but the science books represent a group of 3, and so they can be arranged in 3 factorial ways, and the 5 maths books can be arranged in 5 factorial ways. Okay, so we'll go through that one again. We have 2 groups of books, so that can be arranged in 2 factorial. Inside the science books, they are 3 books, and they can be arranged amongst themselves in 3 factorial ways, and the 5 maths books can be arranged amongst themselves in 5 factorial ways. Okay, next one, C. So how many ways if the maths book must be at each end? Now with this particular one, I think the line approach makes more sense to kids. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So there's my 8 books on the shelf. Okay, so a maths book must be at each end. Now, I have 5 maths books, so there are 5 ways that first book can be chosen, and then I work on the second one, which will be at this end. So there's 4 maths books that are still left. Okay, so I've got 5 maths books that can be put in the first spot, and once I've chosen that, I've got 4 maths books left. And then I've got 1, 2, 3, 4, 5, 6. So in between, I have 6 books that can be arranged in any way they like. So that's going to be 6 factorial. So the answer will be 5 by 4 by 6 factorial. And in this particular case, because you've got a mixture of numbers and factorial, you should actually get a calculator answer. 20. So that's 14,400. If you were thinking, how could you do that with the NPR? Okay, so the maths books, there's 5 maths books, and I have to choose 2 of them, and that gives me my 5 by 4. And then the other 6 books must be arranged amongst themselves, which is 6p6. Okay? So that's what's happening there. In this particular case, we have 2 groups of books that have to be arranged, and then we've got 3 science books that have to be arranged, and 5 maths books that have to be arranged. Okay, so that's that one there. And this one would just be 8p8. So copy that down. Most kids really like the box approach, where you put the numbers in and just play through. Like here, you could have just put 6, 5, 4, 3, 2, 1 for the 6 books that have to be arranged. Okay, moving on. Okay, that was the last one. Just checking again. Example 5. So example 6. No, there's no example 6. So on the Moodle, there's a straight chapter that I photocopied from one of the Jones and Couchman books. So it's 30.2 and 30.3. And that's probably enough work for about 2 lessons. Okay, thanks.